Good morning, friends. In previous lecture, we studied the different equations used for the spur gear numerical. Today, we will discuss one numerical on spur gear. So, the question is a spur gear pinion having 20 teeth is matched with the gear having 43 teeth. Means pinion has 20 teeth and gear has 43 teeth. So we are considering pinion. We will indicate teeth as Z, and for pinion it is ZP, and for gear it is ZG. So ZP and ZG is available. The pinion and gear are made of the plain carbon steel having ultimate tensile strength. Means for the pinion and gear we have ultimate tensile strength. It is SU for the ultimate tensile strength, and for pinion we will use SUP, and for gear we will use SUG. The pinion is to be driven by three-phase induction motor having speed. So we have three-phase induction motor having a speed 1440 rpm. Generally for induction AC motor the speed is 1440 rpm, and rating is 10 kilowatt. We will use watt, so it is 10,000 watt. The starting torque of motor is twice the working torque. The starting torque always in the motor, the starting torque is always more than the working torque. So for that we will use Ka, application factor Ka is equal to 2. If the surface hardness of the gear pair is 400 bhn, design a gear pair with factor of safety 1.5. Assume velocity factor. As we already discussed that dynamic load have two dynamic load can be found by two way. One is velocity factor and other is Buckingham equation. So here they already given that the dynamic load should be considered on the basis of velocity factor. So we will find kV for that. So we have all parameters discussed in the question, so we listed out here. Now the first step is to find the beam strength. Now we know the equation of beam strength is sigma B is equal FB is equal to sigma B into M into Y. FB stands for beam strength, sigma B bending stress, B for face width, M is for module, and Y is Lewis form factor. For that we have to find that this equation should include for the gear or for pinion. For that we will find sigma BP is equal to, we know this equation, sigma B is equal to SU by 3. So here for pinion sigma BP is equal to SUP by 3. SUP is given, it is 600 divided by 3, so 200 Newton per mm square. Same way sigma BG SUG upon 3, 400 by 3, 133 Newton per mm square. Now for we note that B is equal to 10 into module we have to find, and Y for Lewis form factor. Generally in numerical they will give the tooth system is 20 degree full depth involute or 14.5 degree, but in this numerical they even didn't mention anything. So for default we will use 20-degree full depth involute. So for that, equation of yp is equal to 0.485 minus 2.87 by zp. For pinion we are using zp, and for gear we are using zg. So from this equation we will find Lewis form factor for the pinion is 0.3405, and putting equations of gear, yg is equal to 0.484 minus 2.87 by zg. Here we know that zg is equal to 443. We will put in this equation and we can find 0.4172. Now multiplying both sigma and y, sigma bp into yp is equal to 200 into 0.3405, that we already derived. So for the pinion the value is 68.1, and for gear it is 55.63. From this both value we easily conclude that the gear is weaker than the pinion. Gear is weaker than the pinion, hence we will design the gear for the bending. So for the bending equation we will put value of gear. So here sigma bg into b into m into y g, we'll put all values derived. Sigma bg, b is equal to 10 into module is we have to find, and yg is equal to 0.4172. So finally we get the value in terms of module square. So fb is equal to 556.25 module square Newton. Now step 2. Step 2 is find the wear strength. Wear strength Fw is equal to dp into b into q into k. dp is pitch circle diameter, we know the equation, it is m into z, because module is equal to pitch circle diameter upon number of teeth. So from that we can find this equation, dp is equal to m into zp. Zp is given 20, so the answer is 20 into module. Now q, the ratio factor we already know that 2 into zg upon zg plus zp. We have values of zg and zp, put these values, and by solving this equation we can find the q is equal to 1.365. Now for the load stress factor k is equal to, here they they mention one thing, that the gear and pinion are made of plain carbon steel. So for the steel gear and steel for the pinion, for that the k is equal to 0.16 bhn upon 100 square. Bhn is given, it is 400. So putting this equation, putting this value, and we can find k is equal to 2.56 Newton per mm square. Now put all this value in Fw equation. So Fw is equal to dp into b into q into k. dp is 20 into module, b is equal to 10 into module. For q and k we already find the values, so our final answer is 698.88 module square. Here the value is 698, and for FB is value is 556. So it is clear that the FB is lesser, FB is lesser than FW, so we will design the gear pair on for the bending. So what we did in this step, we just in first steps we just find FB value, and in second step we find FW value, and from both values we conclude that the gear is weaker in bending than wear. So for the further equation we will use FB value. Now next is effective load. So effective load equation we know, but here we are using velocity factor, so we will include kV value in the equation. We all know that Ft is equal to P upon V, and V is equal to pi dp Np upon 60 into 1000. We have value of Np, it is 10440. dp is equal to 20 into module. So we will find the pitch velocity in terms of module, it is 1.508 into module. So Ft is equal to P upon V. P is available, it is 1000 watt, and we will put the value of V. So for F effective, considering velocity factor, we have equation Ka Km Ft upon Kv. We know the value of Ka. Km is not available, so we are just putting 1 for that. Ft we already derived. Now it's time for Kv. Kv is velocity factor. Here nothing is given to find the value of Kv. So for default we are using Kv is equal to 6 upon 6 plus V. We have value of V, it is 1.508 into module. So putting this all value in F effective equation, so we will find this huge equation in m terms. Now next step, we already derived that for the further calculation we will use FB. So we know that FP is equal to factor of safety into F effective. We know the FB, the factor of safety is already given 1.5, and F effective we derived this equation, so we are putting this in. Now solving this equation, we will get this equation. It is m power 3 is equal to 35 into 764 plus 8.989 into module. And by trial and error method we can find m is equal to 4.2. Now what is trial and error method? So in trial and error method we are just putting the value of m and find that the LHS and RHS will be same or not. We are continuously adding more and more number in m till that LHS is equal to RHS. I will make a separate video for this method. Now from trial and error method we find the m is equal to 4.2. So we cannot directly manufacture the gear which has module 4.2. We have to choose the module from the standard data book. In standard data book for the spur gear there is a list of module. From that we have to choose the module which is nearer to 4.2. so this value came, it is 5 mm. So module, our final answer for the module is 5 mm. From that we can find this all dimension. So for the numerical, you have to list out this all dimensions after finding the module. Okay, thank you.